Go and do an AD. Open an AD. You've probably heard this when some kind of quality issue popped up. But what exactly is an AD and how to fill it out? What are these 8 steps? How to do it? Well, let's go through an example. Let's go through an example here of an AD report. So this is an example of format, but it usually looks somewhat like this. And it goes D0, 1, 2, 3, 4, and so on, all the way to D8. This is the basic information. By the way, it's good to have a target if you work with some maybe suppliers that have to fix their own problems, or some people inside your organization. It's good to make sure they know that you're tracking how fast they're going to close this AD, and also if you have a dashboard that shows all your ADs, that shows that you they actually close the ADs. Okay, so problem symptoms. What's the problem? Okay, try to put some information in simple terms here. Okay, corrosion issues on the product. What product? Okay, you need a SKU number or something. After some time in use. Okay, no need to be very specific here, but be clear and concise. Okay, the team. Again, if maybe your quality manager is the leader, but maybe some of these people would be the production manager and the process engineer and so on at the supplier maybe. Okay, if you're doing this with a supplier. Otherwise, it might be people inside your organization. Okay, so D0, D1. Team members, by the way, if you can have people who know the process very well, it's always better. And if you can have people from different sort of specialties or expertise, it's usually better. Okay. Problem definition. This is the time to be very specific. Okay. So the 5 W's and the 2 or 3 H. Okay. Sometimes we can add how often, for example. Very specific. So who found the problem? Okay, end users after it been in use for about half a year. Okay, end users. Okay, so it was in the field. Okay, what part has the problem? Okay, so put the part number, the serial number, or something like that. Very specific. What's wrong? Corrosion on the front cover. Okay, what was happening? Okay, there's abrasion and signs of corrosion, and maybe it's linked. But try to really give more context here. Where? Okay, well, here in this case, field, but it could be found in a testing station. It could be found in a lot of steps inside the hood process. And where on the part is it located? Okay, see photos. Very often, it's good to show photos or videos so people really get it. When was it found? Has it recurred? When in the process was it observed? Okay, you go through all these details. Why is it a problem? Okay, so this might be very obvious to you, but okay, let's break it down. Really, all of this is break down the problem. Go through the first analysis. Okay, first level of analysis. How was it found? How many parts? How often? Okay, if you have some data, maybe you can plot them. Maybe you can see if there's a pattern. Any attachments that are visual are always a good thing. So if you spend 10, 15, 20 minutes going through this, maybe more time collecting some data and putting them together in a visual way, all the rest will be much easier. Okay. At the same time, you might also be thinking of what to do in the very short term. So maybe, okay, we found something, or maybe users complain about some problems. Hey, but we are making these same products right now. Like block shipment, don't ship anything right now. Get more information first about the problem. Add an extra test or something. Okay, you maybe, for example, contain and scrap all of that old inventory, for example. Okay, scrap is a bit extreme. Maybe testing, in this case, maybe some reliability testing to replicate the effect of someone wearing that product. Okay, right now, don't waste any time. Do something. Very often, there's something that makes sense. For example, human sweat test. This can take a long time, so might as well start it right away if Some people think this might be a reason, a cause of this problem. Okay, so you spend some time collecting some data, being very specific, breaking the problem down like this. You do what you need to do very, very fast. Okay, and it's like a to-do list, basically, an action plan. After that, you think, you step back and you think, what is the root cause, or what are the root causes? Okay, so summarize, the thinking. Okay, pick up some samples, send for reliability testing, da 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 da. All of them pass the test. Okay, so it might not be a problem of the design and the way it's made. Maybe it's a problem of inconsistency in the process, or maybe it's the wrong process. We don't know. So at the plating factory, always go on site. This is a very, very important point. Don't just do this on your computer trying to imagine things. This doesn't really work very well. Go on site or send people on site and observe. Okay, so the thickness is too low. Okay, they do this plating with these elements. Okay, and the key parameters are out of control. Okay, it's very inconsistent. All right, so sometimes it's thin, sometimes it's thick. When it's thinner, obviously, it's easier to get corroded, to get used up. Okay, so these are some interesting findings. So what are the root causes? We dig a little bit deeper. So root cause number one, that kind of plating is not suitable for avoiding corrosion. Okay, simply Cu plus Ni, not good for this application. Well, a little bit late to find out about it, but better than never. Root cause number two, unstable process. So the thickness and the adhesive force of the plating are probably inconsistent. Okay, and the end products, well, some of them, if it's very thin and the adhesive force is too low, will get corroded faster. And root cause three, well, as part of their new product introduction process, the assembly supplier did not evaluate the plating process. Because think about it, this is a big problem, but the root cause of this is actually this. The supplier, the guys who do the assembly, did not think, what kind of plating do we need? Okay, so if they had a good NPI process, they could have avoided this problem and maybe also this problem. Okay, so some problems are at the level of the plating factory, some of them at the level of the assembly supplier. Okay, just to prompt people, why was it made? Okay, probably key parameters are out of control and the process itself does not appear suitable. Why was it shipped? Well, because the testing was insufficient. Totally insufficient. If you want to replicate the use in the field, you need to do a test with human sweat, which can be tough on some products. Okay, this also points to maybe an inappropriate testing plan. Now, based on these root causes, what are the corrective actions? Well, usually, if this is clear and you really break it down like this is not very complicated. It just goes, it flows naturally. So request a different kind of plating, okay, adds human sweat corrosion test requirements in the assembly supplier's IQC documents. The key parameters of the plating need to be checked from time to time. Okay, is it steady or not? Is the process steady or not? Okay, there are ways to check, for example, adhesion and thickness. And production staff all to be aware of the new process during production, obviously. So this becomes an action plan. So it flows naturally from these issues and this. Okay. Now you have an action plan. People say they do it. Okay, great. Well, what about in the next batch? Have a look. So over 6 months, okay, done and verified, and they should keep records of the plating parameters, for example. Okay, complete and verified. And then also, for example, if this is really, really important, an audit of plating operations. When they're running it, have someone go there and do it twice a year. This is an example, okay? Then after that, to prevent recurrence, again, action plan, how to make sure this does not happen again, process changes, ongoing controls, and so on. Actually, some of this was already here. As the buyer, request a test report for every batch, for example, and then update the control plan. Okay, control plan here, and also the work instructions. So control plan for the incoming QC, what to do and how to check it, and the work instruction for the plating supplier. Okay, update these documents. And D8 is, okay, just to mark it's all closed, we close it, we had success, recognize the collective efforts of the team, and that's it, the D8 is completed. So as you can see, it can be a lot of work, a lot of going on site and observing. Actually, here we have several root causes. We could actually, if it's complicated enough, from here, duplicate that file 3 times, and then keep going with D5, D6, D7, D8 for every root cause separately. Sometimes it makes better sense to do this. It's easier to track. It's easier for everybody to understand when it gets a little bit too complicated. In this case, it was sort of an edge case, I would say. You might have benefited from that also. Okay, so a lot of paperwork, a lot of people hate it, a lot of people in production hate doing these kind of things. Very often quality people have to step up and do some of the work, because it's basically documenting things. It's a little bit like pushing paper. But if you really want to spend the time, do things nicely at the root, fix the issue at the root, and then not release any of the pressure and keep checking and make sure that everything is documented the right way, and people are aware of the problems, and maybe set up an extra audit layer to catch the let's say the supplier overlooking some of these changes and forgetting about it. Well, if you really want to get very serious, this is not a bad approach at all. Not a bad approach at all. It's very directive. People just follow this and give them 1 or 2 examples. Have one person who is used to doing root cause analysis, and you can get very good results. Well, I hope this was useful, and don't hesitate to contact us if you have any questions or if you need some help with some issues that you have in your supply chain. Thank you.